Assalamu alaikum wa rahmatullahi wa barakatuh. Today we'll be talking about the HVAC chapter in our KNX advanced course. The HVAC chapter will have 2 questions in the exam, in the theory exam, and 22 questions in our question bank. The HVAC chapter is talking mostly about heating, cooling, ventilation in general, and here in our advanced course it's mostly a basic chapter because we have another course just dedicated to the HVAC technology itself. So if you want to know more about HVAC, then you may consider taking the HVAC course itself. And also here you will notice that mostly we are talking about heating, not cooling, because as you know that it is the most energy consumption unit in Europe is the heating itself. Cooling is not a big issue, especially in the old days. Now it's becoming some kind of an issue. But heating is the big issue, consuming a lot of power and energy. Okay, so the final chapter is more biased via heating, not via cooling. Okay, the concept here is trying to tell you that you should have your room temperature configured in a way that which is suitable to the room itself, and to make sure that you are in a comfortable way without wasting a lot of energy. So in the bedroom maybe you have an 18 degree, in the lounge maybe 21 degree, something like that. Okay, you'll notice also that it's more biased via heating because as you can see here in the as an example, hallway is 16 degree. So definitely you are trying to heat, not trying to cool. Okay, why? Because 70% of the energy consumption in houses in Europe is going to heating and warm water. So here you can see it is specifically saying heating. Okay, so 70% of the energy consumption each building is going to heating, which accumulate to 30% of energy consumption in the whole country. So if you are trying to save power consumed for heating in a country, you are really affecting the consumption of the energy in the country itself, because 30% of the energy consumption in a country is going to heating. Okay, good. What is the goal? That to have to convenience and comfort with the lowest use of energy. So you have to make sure that you are using the energy in a very economy way to reach the level of convenience that you have. Okay, KNX offers what? KNX offers inverter room control, heating and cooling circuit control, and boiler control. We'll talk about this now. Let's talk about something they call it energy certificate. So each building in Europe should have this kind of certificate. So you have to go via some regulations. Through these regulations, you have a lot of checks in the building, checking a lot of things, and based on this checks results, you get a certificate saying that this building is a green building or this building is not really green building. So you got something like that. Okay, and the conclusion here that really home automation or KNX systems or system that allow automation of energy related to heating is really now a must in most of the buildings. Okay, how to plan the heating system? You have to consider all of these things: heating curve, okay, capacity of the heating elements, okay, heating control, and the cost price of the primary energy you are using to heat. Okay, some comparisons here, comparisons of foil compared to electricity. By the way, storm here is electricity, by the way, but it's in general. So this is compared to electricity, this electricity. Okay, and then another one for the energy prices per each year. You can see that's increasing, of course. Another one taking inflation or not taking inflation into account. So you can see that's a little absolute number. Here is taking about compared to wood pallets. Okay, the blue one. You don't need to memorize this, only giving you, let's say, a hint about how the energy price is increasing each year and which one is increasing more. You can see that electricity is increasing in a, let's say, linear way. However, other energy consumption or energy sources are not increasing in a linear way. Now we're talking about the heating system. You don't need to memorize this. You need only to know that there is a boiler which will give you hot water flow in these pipes. Then you have valves, okay, that's controlling the flow of the hot water. Some sensors controlling which valves should be opened and how to be opened to make sure that you are reaching a specific degree in the building you have. Okay, so that's it. That's what you need to know about all of that. Types of heating you are using, the heating device you are using is very important depending on the usage you need. So as an example, if I'm using it in a residential building or residential houses, hotel houses, apartments, then this is the preferred one. Why? Because first it will give you a quick response, which is very important, because when you are going to a cold room, you need to get it as warm as fast as possible. Okay, so you need something that's very fast. This is very famous in Europe, by the way. Okay, so this is the heat water connector heatings. Okay, this is useful for what? Residential and functional buildings. Reaction is quick and flow temperature from 35 to 70. Okay, and it's using continuous 0 to 10 or 3 volt steps or 3 steps. Okay, if you are using under floor, because the floor itself should also be heated. Okay, then you can use something that's slow, something like that, and this is the flow temperature that you can get. And then you can go from one usage to another. As an example, is the electric heating. You use it in Egypt many times. Okay, this electric fan heating, then it's a very quick response. Okay, rooms that are rarely used. Okay, because you use it on demand. Okay, as additional heating and single and multi-level. Okay, so you can check which device you should use depending on the nature of the device and the nature of using the room that you are using. Heating curve is simply how the system will start changing from one temperature to another based on the control value you have, and it's what we call a heating curve. Okay, so it will go gradually to a specific number and start oscillating between the desired number and the actual number. Okay, capacity of the heating elements, what you should consider when you're putting a heating element in. Here is the radiator. First, you achieve the uniform distribution of heat. Heater should be placed in the coldest place, generally under the window. So here is under the window. And the heater should at least be as wide as the window. So if this window is 1 meter, so the heater should be at least 1 meter, maybe 1.2 meter or something. Okay? But this is for the heater itself. So how about the thermostat? Okay, because the thermostat will be the one reading the temperature. Because in this whole system, I have a thermostat reading the temperature. I have a thermostat reading the current temperature. Okay, so I have here a thermostat like this one in the room reading the temperature. Okay, and it also the one that I'm changing the temperature. So it will tell me that temperature now is, let's say, 12, and I will tell you I want to increase the temperature to 22. Okay. So this one should also be able to read the temperature, which is as accurate as possible. Okay, so better you put it this height. Okay, 150 centimeter, which is almost your height. You don't put it too low or too high. And from the wall, from the door, like 20 or 30 centimeters, so it's not affected really with opening and closing the door. And you shouldn't put anything else in the room affecting the temperature reading, like other room temperature controller. Okay, something like that. Heating control. These are some types of heating control that you can use. Okay, and control options according to the actuator. So the actuator that will control the boiler or the heating control, mostly they have direct heating circuit or mixed circuit. In direct heating circuit, you only have a pump that's opening or closing, and in a mixed circuit, you have more than this, like opening, closing the mixed valve. Okay, or controlling the boiler as well. The heating system might come with this not yours, because the heating engineer will be doing that. But you know that you will have some maybe adjustment because you have multi-level heating system, and maybe you need to open one or close one depending on the desired heating you want. Okay, most of this information, by the way, you don't need unless you are really working in this field as a heating engineer control, not a KNX controller. In the KNX, we only need specific information from the heating engineer or the cooling engineer from the AC guys, but you don't need to know all of that. The idea of the KNX chapter in this chapter to make sure that it's closing the gap between you and the heating engineer, so at least you know how he's doing that from a very basic point of view, so maybe you could be able to understand each other in a better way. So, how to integrate the heating system with the KNX? Okay, In the KNX system, you will use individual room control, which we said is a thermostat. This is the unit that you put in the room. And heating system control, which will control the pipe or without controlling the boiler on one without controlling the boiler. And this is the one that will control. And then you link this thermostat with the actuator controlling the boiler or the gateway controlling the boiler to make sure that the degree that you choose in here is achieved by controlling the actuator, which will control the boiler or the heater or anything like that. This is the whole concept that also will be doing in the practical part together. Okay, he's saying also that in room control you have two-step control or continuous control. The concept is simple. You have a set point temperature, you put it in the thermostat, and you have an actual temperature, okay, read from the system coming to you, and then the difference between the desired temperature and the actual temperature is going for the thermostat as a control algorithm, and it's taking that to control the valve controlling the heater itself. Okay, good. But then how this is controlled, you have two ways: a two-step control, which is a cheap one, okay, not precise enough because it depends on opening and closing the valve. So if I have a 20-degree currently and I want to reach, let's say, 25, then it's oscillating between, let's say, 24 and 23. Okay, so it's like that. The accuracy is the hysteresis, okay, and here is 3 degrees, so it's oscillating between here and that with an oscillation of 3 degrees, okay, up and down. So it's simple, okay. It is slow because you cannot just switch the valve on and off that easy, okay, because it takes time to switch off the valve or to close or to open or to close the valve, okay. So it takes time. Sometimes it takes up to 3 minutes, okay, so it takes time, okay, and the temperature is oscillating, okay, around set point. Then you have another way, more complex, with using an algorithm, okay, a PI control, okay. PI is a way of control, taking the feedback and put it in a very, let's say, complex algorithm to reach a point. And this is more complex, more expensive, but the outcome is more smooth, like as you can see now, okay. A room thermostat will have specific functions. You have here a knob to control the temperature, okay, up or down. You have modes to choose the mode you have. Modes are simply predefined categories. With each category has some predefined values. Let's say an economy value will have, let's say, the degree going to 25 degree or less if you are using a heating, okay. So it's not consuming a lot of power. If you go to comfort mode, then no, it will have faster way of compromising, consuming more power. Here also you can see you can control the fan itself. And here you can see should I go to the cooling mode or the heating mode. Also you can connect your thermostat to or your KNX system in general to a door window sensor. So if the window is open, you can also see here that the window is open, then maybe you can take some specific actions, okay. And each one of those will have a KNX object, group object, okay, maybe with 1 bit, maybe with 1 byte. And these bits and bytes and the group objects are the one you are going to link in the group address to the actuator or the gateway you are using, okay. And this is what we're going exactly to do in the practical part, okay. What other elements I might need in my system, okay. I also might need a time switch to activate these things via time. So maybe during evening, during night time, I need the economy mode, but in the morning maybe I need the comfort mode, okay. A window contact also, which can be connected via binary input. Display on a LCD or something to see the temperature and the other things. PIR motion sensor, so when I'm not in the room, maybe you can turn off the AC or vice versa. And also a logic to combine this together if I want, okay. He's saying that one way of connecting the thermostats together with the boiler is using a gateway, and there are many ways to connect heating elements to KNX systems. Maybe a gateway, maybe an actuator, okay. Now we are talking about fan coil. Fan coil is a different concept because we don't have just a valve, but we have the hot or cold water, plus we have also fan connected to the system. So most of the system is based on hot water flowing in the pipes or cold water flowing in the pipes, depending should I use it in a heating way or a cooling way. And in each area you have a fan, and the fan you can control to the speed of the fan. So if I have hot water and I want more heat going, then I increase that speed of the fan, so it's blowing air in a more aggressive way, so it's giving me more hot air or vice versa. Okay, so this is the concept of the fan coil unit in general. So it's a fan coil unit. It has hot water circulation, cold water circulation, and heat generation, and a fan, of course. Okay, this is the basic of it. So mostly you have two pipes for cold, two pipes for heating. Okay, so here the water is flowing and getting back in a separate pipe. Also here is flowing, this is the hot water going back in a different pipe. Okay, this is a condensate tray. Got fine. And there is a filter here, and then this is the fan or the blower, and you can control the fan or control this valve as well. Okay, now there are three variations. This is the one that we talked about. So we have complete two pipes for cold, complete two pipes for heating, and then we call it 4-pipe system. Here you have a common pipe here, so we call it only 3-pipe system, which is not used, by the way, in a very much way. So normally what you have in your system is a 4-pipe or a 2-pipe. If you have a 3-pipe, then you configure it as a 4-pipe because you have two valves at the end. Here you have only one pipe, 2 pipes, sorry, because one is going this direction, one is the other direction. This direction. Okay, and only one valve, so we call it only 2-pipe. This one you will use it for only cooling or heating. In the Gulf, we mostly use this one because we use it only for cooling. Okay, but you cannot use it for both. This you can use for both. The integration with KNX, first you have a device to control the fan coil unit, which we call it FCU actuator, connected to a thermostat. So what you have here, as fan coil units usually do not have an integrated KNX interface, each unit requires a fan coil actuator for activation. This is a KNX device. Triggering of the fan, which can be switched on and off at different speeds. This we use via the KNX group objects. Fans can also be electromechanical or electromotive. They can be triggered via 2-step control, we'll talk about this, or via switching or continuous bias control. The actuators have a first or load contacts as mentioned in the 2-pipe variant, which enables an electric booster heater to be connected. Okay, binary inputs are also integrated in the actuator to monitor the condensate tray, okay, the one that including the water, or to query window contact, for example. Okay, so the concept is very simple. Let's talk about the concept here before we go about the fans. So you have first you check the indoor unit of your fan, of your AC, of your fan coil unit AC. Okay, you check what kind of fan it is using, what kind of valve it is using. Okay, is it 2-pipe or 4 pipes? Depending on this data coming from the AC, you choose your fan coil unit actuator, the KNX device, which should be controlling this. Okay, once this is chosen, then you can put a thermostat in the room, link it to this fan coil unit via KNX bus or via KNX media in general, and the linking is also via group addresses. So you check the fan coil unit and take what you need from the group objects in here and the group address in the thermostat, put them together in a common group address, and then you'll be able to control the AC itself. And this is what we are going to do in the practical part. So it's not covered in details in here, but it will be covered in details in the practical part. Okay, the control of the fan can be set in 2 different ways. One way is the interlock, so only one will be on and the other 2 will be off. To achieve higher speed, then output 3 will be on, but the other 2 speeds will be off. Or to accumulate, so if I achieve the higher speed, then the 3 output will be on, and this will depend on the type of AC you have. Okay, and most of the fan coil unit will be configured depending on that. Operating modes in the fan coil unit, as we said, in the heating mode, we have a comfort mode, standby mode, night reduction, frost heating protection. Also, this you can activate via the KNX. Integration in KNX is very simple. You have the fan coil unit here, and either you put a gateway or a fan coil unit actuator depending on the AC you have. Some ACs will not work directly with fan coil unit, so you put a gateway. Okay, a gateway is simply a device which is connected via a specific port to the AC part, and then from to KNX to the other part. And then on KNX you can put the thermostat, you can have presence sensors, you can have binary sensors, okay, keypads, whatever you want. And in this way you have systems that support unidirectional communication, only sending data, or bidirectional communication where you send the data to the AC and also receive data like status, like from the AC itself. Then it's talking about some regulation, what kind of the data point type I will have. So it's saying that you will have a data point type for each one, for each thing in the AC. Here are the group objects you will be using, and this will be covering in the practical part, inshallah. But you can see here that for each let's say property in the fan coil unit, you have a group object, and these group objects in the actuator should also be found in the screen, the LCD or the thermostat. And then when you connect both together, you get the desired data that you need. Okay, here's the control via the KNX gateway. What else I need in my system? I need sensors. As we said before, sensors will read physical data like temperature, like brightness, okay, like wind. So what kind of sensors I can use in my system in general? KNX system or HVAC system via KNX system as well. A temperature sensor is a very important one. Mostly in also you'll find one integrated in the thermostat itself, and we know that it's reading data both based on 2-byte system and it's reading in Celsius or Kelvin. Brightness sensor, okay, which reading the brightness or the amount of light using lux, okay, also 2 bytes, floating number. Wind sensor, which will detect the wind speed, something like that. You can have also a rain sensor, which is detecting if there is rain coming from outside. Most of those sensors are outdoor, of course, okay. And then you can combine all of that together. So if I have rain, then I might need to close the blind actuator, okay. Solar radiation sensor, which will detect the solar power coming from the sun, and based on that I can take actions like what, like let's say, oh, measure shades so I can have more energy coming, or let's transfer our energy input from the normal energy supply to the solar energy grid if I have one. Okay, those can be combined into something called weather station. So it's a device like that, and you will see someone like that, some device like that in our practical part as well. Okay, and it has a lot of sensors together. So it's a group of sensors, maybe a wind sensor, maybe a temperature sensor, lux sensor, humidity sensor, all a lot of sensors in one device. You have also air quality sensor, which will measure something like humidity. You can have also sensors that which is measuring CO2, carbon dioxide level. Sensors for humidity, of course, okay, with different types of sensors, some with probe, some without probe. And that's it, a lot of sensors and HVAC unit. What you need to know from this course, that you can control HVAC different heating or cooling units via KNX, via gateway or via actuator, and the interface of the user mostly at the thermostat, not a normal keypad. Normal keypad will not fit. You can have a lot of sensors connected to your system as well to make sure that you are getting the best of your system. And depending on the fan coil unit you have, or the AC that you have, or the boiler you have, or the heating system you have, you can put your actuator. Maybe you have an actuator, fan coil unit actuator. Maybe you have a gateway to connect your system to KNX, or maybe you have a device that will send IR commands to your system. So the system, like a split system, can be also controlled via KNX. Okay, if you need more information, then you will see more information about HVAC in general in our HVAC course. Okay, and if you have any question, let me know. Assalamu alaikum.